Good morning, guys. Well, as the title explains, my Sheldon lathes have just blown up because I had the back gears adjusted wrong, or I did something wrong, and the lathe just exploded. And if you haven't figured it out already, that title is clickbait, because this is all just bullshit. So I'm going to take a couple minutes, going to go over the back gearing on a Sheldon lathe, because this is primarily going to be of interest to the Sheldon guys. But as far as my little rant about the stupidity of the discussions that go on these internet forums, it kind of pertains to most of these forums. I found some to be better than others, but yesterday I was looking at stuff and watching a old Chevy engine, stove bolt engine thing, where some guy was claiming he'd bored out his 216 engine and stroked it so it was made more horsepower than a 235, and bored it out to 235 specs and everything. And somebody, not too politely at the end of the discussion, pointed out that that was bullshit, because you'd be having air all the way around all your pistons because there's not that much material on the block. So anyway, neither here nor there. The thing about Sheldon lathes now is questions about back gears and noise back gears has come up. So we've got now discussions about how your cast iron lathe is going to shrink over the years, and about how, let's see, what other foolishness do we have going on? BMW, you know, their racing team, they peed on their castings and ended up using old wore out BMW car engines because they were so much better seasoned after being run in a standard street car, and all kinds of other bullshit that has nothing to do with Sheldon lathes, basically, other than just somebody wanting to hear themselves talk and tell how great they are and how they've converted their Sheldon lathe over to CNC and it's the best thing in the world and all those other things. So anyway, I'm kind of finished with my little rant, so let's just go on. We'll look at these back gears. Now, this is a Sheldon SWQE. I'm just giving the numbers. I'm not giving what I was led to believe this lathe was initially and all that stuff, but this is an SWQE. We'll go handheld with it. I'll show you the data plates, and we'll go on and show how the back gear is set up on this particular lathe. Now, other models are probably set up differently, but this is the SWQE, which is, I believe, the same machine that Keith has that I initially asked about back gears and that type of thing. So I'm going to take just a couple minutes. We'll go over, we'll see how it's adjusted and what it's going to do. Here's the lathe. Here's the data plate. I have two of these lathes. The one I've been running for years, exact same machine with little variations, but the exact same machine. So here's our headstock cover. Let me get it out of the way. There it is, inside of the headstock. Now, I will say, I've been running the other Sheldon lathe for more than 35 years. Great gunsmithing lathe, couldn't ask for a better one. I've wore it out. When I got this machine, it was already wore out. The other machine was already wore out. When I run it in back gear, it howls, and there's been a tooth repaired someplace on this gear. It clunks every time it goes around. You know, I primarily use it for threading, affects nothing. I get good results with it, always have gotten good results with it. I'm whining now because that machine's wore out more. But anyway, we look at the back gear on this one, exact same thing. We have a split bushing here. All this does is this set screw adjusts the tension on it, as Keith had surmised earlier. It's not offset, it's just a bushing that supports this end of the shaft. We go to the other end of the shaft, and you'll notice there was no slot in this end on that end. There's no slot on this end, no slots in either end of the shaft. The way it works is it's all, your tension is all controlled by where the handle set screw is positioned. This will rotate around this portion of the shaft. So it's where it's set. So when you have it engaged, come on, get in there. It goes into that detent, that's engaged. That's where you want to set your engagement for how much tooth engagement you want on there. Once you get that figured out, you tighten down the set screw, that locks it in position. So we're fully engaged right there. When we disengage it, rotate it down, it goes in the other detent, and we're clear for our back gears. That's the adjustment for back gears. When you look in here, the shaft goes through the shaft itself. From this point on, you've got a straight bore through the back gear. The two gears itself, this is one unit. It's a straight bore through there. Okay, you see it spinning concentrically. You see the outside end of it spinning concentrically. There's nothing that moves there. The shaft that goes through makes it to this point, then it is offset all the way through to this end, where when you look at this end, it still spins concentrically around the shaft itself. When you adjust it, you move the handle. If you watch this, the positioning will change on where it sets that gear. There it's engaged. That's the only thing that is. There's no slot in either end of the shafts or the shaft, you know. That's the way it works. No other crap that anybody else has to say about it is really relevant. That's it. You set your adjustment by that right there, and that's all there is. So there you go. Now see, I posted a post to the when this was originally asked on the list, and I gave bad information. I was thinking of something else when we were talking about the slot in the end, and I was thinking about this slot too. So I've gone back and deleted that post because it was bad information. I can admit it's bad information. I don't have to go on and double down and tell you how great I am. You know, I make mistakes too. I learn something every day. So these machines are 50 years old. Every one of them is going to be different. Adjustment on every one of them is going to be different depending on how they've been run for back gear, as an example, how much engagement they've had for years. You change that, you are going to change the engagement, and every machine is going to be different. You know, when you've bought these machines for $1,000 or less, $1,500 or less, whatever the case may be, after this long, no matter what they tell you, no matter what you try and post on the internet, these are wore out machines. You know, they're going to be worn. They're going to be worn in different manners. So everyone's going to be a little bit different adjustment-wise. There is no hard and fast rule to them. You go through, you do the best you can with them, and they run fine. Like I say, my other machine has been run with the same engagement. I've never changed the back gear engagement on it. It was loose when I got it. It banged every time you went around, and it howls. Works perfectly fine. Why worry about it? Let the machine do what it was supposed to do, machine the best you can with them, and you can get good results. So I've gotten a lot of good precision results, precision to my standards for gun work for 35 years. So now I consider the machine to be wore out. That's why I'm not doing as much with that machine, and I've been working on this one. This will replace that one. That machine will become a turret machine, strictly a turret machine, so it'll serve my purposes for what I want it to do, and that's all we can ask of any of these machines for what we've got in our shop. You know, put them in there, use them, enjoy them. Don't get tied up in this internet rhetoric, and you know, you'll be a whole lot happier. So it used to be that the number one cause of breaking gears in the headstock, whether it was bull gears, back gears, whatever the case may be, was because you were putting it in back gear, engaging the back gear, and taking your chuck and spinning it on or banging it back off one way or the other. Now it seems on the big internet list that the main cause is because you've got the settings wrong or the engagements wrong between your back gear and your main gear. So the broken tooth that's on my other Sheldon, I surmise it was broken because of doing just that, banging the chuck on and off. Now there again, in 35 years, I've not had any problems with that gear engagement at all. I haven't broken any more teeth. I haven't done anything, and I abuse that. I'm guilty of taking my chucks and spinning them on to where they're close, giving them a little snap to bang them on the rest of the way. To take them off, normally I'll put a chuck key into the chuck key slot there, and I will bang them back to pop them loose. Now, I've not broken any gears. I could potentially, I'm aware of that danger, but I haven't had any problems. It's a practice that I've done for years and not had a bit of issue with. Now, if these back gears are worn to the extent where you've narrowed them down, they've got track marks in them where you've worn down at the bottom of where one tooth's engaged and the other one, narrowed them down, then you change that engagement and do that. Yes, you probably stand more of a chance of breaking those gears off, chipping the ends of them. I do see one of the back gears on the main back gear on this lathe has a little chip out of one corner. I would imagine that's from some crap getting down in there, chip getting stuck, something like that, because it's just a small chip. Where the other one, the tooth was pretty much gone, it looks like, from the repair. Why, I would imagine it was probably from banging that chuck on or off at one point in time. Your mileage may vary, you know, I mean, you do what you're comfortable with. It's worked fine for me. These lathes are supposed to be exactly the same. I don't remember the difference in serial numbers off the top of my head or the difference in when they were manufactured. What I did notice early on is the spindle on my older lathe, the threads on it is larger than the spindle on this lathe. So the chucks that were on this lathe were very tight on that lathe. The chucks on the other lathe spin up on this one just fine and lock on. So there again, if you've got a chuck that's sticky, something like that, you may have more problems. They need to be fitted right, but that's a combination of wear and the way they were fitted. So not a fault of any particular thing. It had nothing to do, in my instances, I don't believe, with back gear engagement on the machine. So that's where we're at with it. I have kind of fitted them to where they'll interchange. I'll make them a little bit more. All of the other lathe, once it's converted to a turret lathe, will not be utilized. Those chucks won't really be utilized on that, with the exception of one or maybe two of the chucks that I have for that. This will get most of the chucks changed back and forth, so I may be building other backing plates to match this chuck. We'll see what happens when I get that far. But there again, more rhetoric that you hear on the internet. Everybody's got to make their own decisions. Same way the idea that, well, your chuck's going to unscrew if you run it in reverse. Never had an issue on that lathe. I do snap them down to where it engages fairly solidly, but not excessively. I mean, I'm not really reefing that chuck down on there. So that's all more of the crap that you're hearing on these discussion forums. You got to figure out what's true and what's not true. That's how the back gearing works on an SWQE machine. So there we go. Comment suggestions, leave them in the comment section for me below, guys. And as always, thanks for taking the time to watch.